Hello and welcome back to another episode of Math with Sohn. Today we are going to be doing some independent and dependent events with some funky looking stuff. It's not hard. This is easier than last video, but it does look scary. That part I cannot lie about. It does look scary. So there are two formulas that you need to know. One of which we're going to start with is the probability of A and B, which is what that looks for. Like probability of A and B is equal to the probability of A times the probability of B. And that is only true if they are independent events. Independent events. Okay? That is not true for dependent events. It is only true for independent events. All right? So that's the first formula. And while we're here, we might as well write all three. Okay, so that's the first one. The other one that is true is the probability of A occurring given that B has already occurred. That's what this means. So find the probability of you being, blue-eyed given that you already have blonde hair. Okay, that's probability of picking an apple given that you already had a bath. Doesn't matter. Is equal to the probability of... I messed up my parentheses. Probability of A and B divided by the probability of B. Now, if memory serves me correctly, on the Math for College Liberal Arts formula sheet, you should be able to get this formula. I did teach this class like 3 years ago, and in the past, they had it on the formula sheet that was provided on like every CFA, the Common Formative Assessment stuff. Okay? The other variation of this is the exact same thing, but it's the flip. You put an A on the bottom here, and this will be probability of A and B, just like before, divide by the probability of not B, but A. So the number, or letter, the letter that is here is the letter that's on the bottom. The letter that is here is the letter that's on the bottom. All right? So let's do a few problems. I promise they're not difficult. And that you will get it. Okay. Let's do it. So, probability, this first section, we're just determining if they are independent. Probability of A, 11 over 20. Probability of B, 1 over 2. Probability of A and B, 99 over 400. If this is independent, then that means that 11 over 20 times 1 over 2 must equal 99 over 400. So we're going to use our fraction bar in our calculator. We're going to hit fraction bar, 11 over 20. And I'm going to multiply by 1 over 2. And that is equal to 11 out of 40. Which last time I checked, those two things are not equal. And if that is the case, then they're not independent. Let's make sure that 99 out of 400 doesn't simplify down to 11 out of 4. No, it doesn't. So those two things don't equal. If they are not equal, they are not independent, and therefore they are dependent. That's as simple as that. You do need to show your work. Show your work. Let's try another one. Maybe this one will work out. Does 3 out of 10 times 1 out of 5... does that equal 3 out of 40? The answer is no, again, because 3 out of 10 times 1 out of 5 is 3 out of 50, and 3 out of 40 does not equal that. Therefore, they're dependent. Oh my gosh, dependent. Not independent. We got to find one that wins. Does 3 out of 5 times 1 out of 2 equal 9 out of 25? No, it doesn't. Oh my gosh, none of these are going to work. That is 3 out of 10. 3 out of 10 does not equal 9 out of 25. So that is also dependent. I need to find an independent one. All right, I got my answer key in front of me. Okay, found one. That is independent, finally. Let's see if this one actually works. 28 is supposed to be independent. 2 out of 5 times 3 out of 4. Does that equal 3 out of 10? Well, 2 out of 5 times 1 out of 4, 3 out of 4. You could use your fraction button in your calculator, but I'm going to multiply 2 times 3 to make 6, and I'm going to multiply 5 times 4 to make 20. If I did it in my calculator, 2 out of 5 times 3 out of 4 is 3 out of 10. What does it say it's supposed to equal? Finally, 3 out of 10. That is a true statement. If it is a true statement, they are independent. So if it is a true statement, they're independent. If it's not a true statement, then they're dependent. Independent, equal, which 6 out of 20 does simplify if you divide them by 2, 3 out of 10. All right, so that is a true statement. So those are really easy. You should be able to fly through those super fast, all right? I'm trying to make this one a shorter video for you because I think that you might watch it after the video from yesterday, or maybe just back to back. All right, probability of A, 9 out of 20. Probability of A and B, 11, that number, 117 over 400. Find the probability of B if they are independent. Okay, well, what was the formula? The formula was probability of A and B is equal to probability of A times probability of B. So let's just fill some stuff in. Probability of A and B will be equal to the probability of A times the probability of B. So probability of A and B is 117 over 400. Probability of A, 9 out of 20. Probability of B, we don't know, so we have to multiply it by the probability of B. I included an extra parentheses. Let's ignore that I put that there. And I'll rewrite it for you. 117 out of 400 would equal 9 out of 20 times the probability of B. I did it again. All right, probability of B. How do we solve that? Well, this is no different than saying 200 is equal to like 4 probability of B's. So we would just divide by 4 in this case. We're going to divide by 9 out of 20. So we divide by 9 out of 20. You divide by 9 out of 20. That cancels that off. So that means we have to do 117 over 400 divide by 9 out of 20. And you can use your calculator, and that will equal the probability of B. Out of room on my paper. There we go. So in my calculator, I'm going to do that. I'm going to do 117 out of 400 divide by 9 out of 20. And that is equal to 13 out of 20 as a final answer. Yippee. We got one more for today. One more, and it's going to use one of the fancy formulas. Okay. What do we have? We have probability of A given B. The B is on the bottom of this fraction. The B should be on the bottom of that fraction. So we're going to use this formula right here. So we have probability of A and B is going to be 17 out of 20. So I'm going to do 17 out of 20. That will equal probability of A and B. Probability of A and B is 119 out of 200. Divide by the probability of B. So we have probability of B here. We don't know that. We're looking for that. And we have a multitude of options for how to solve it. So let's see what would be the way that I would solve this. Well, you could cross multiply if you remember that from geometry, or if you just remember that. But if you don't remember that, you can multiply by the probability of B over here and it would cancel. And you get a probability of B over there. And now we're back with what we had on the first problem, where we have the probability of B, which P parentheses B just means probability of B. It's not a multiplication. Times the 17 out of 20 would equal 119 out of 200. So we have something times something equals something. We have to divide by that 17 out of 20. Divide by the 17 out of 20. It would go away. I know the equation might intimidate a few of you. That is A-okay. We're going to get better together. We have to do 119 out of 200 divided by 17 out of 20. 119 out of 200 divided by that. I don't have my answer, so I'm going to have to do it. And my calculator fell, so I have to use this one. We got 119 out of 200 divide by. For those of you that don't know the fraction bar on your calculator, you hit alpha and then x, and then it turns into a fraction. You get 17 out of 220. And we divided, and we get 7 out of 10. All right. Another way that you could think about this is in the beginning we had this. We just ended up flip-flopping these. That's a trick. These two just flip-flopped, where this stayed on the top of the fraction, then we divided by that thing on the bottom of the fraction, which you may remember from some other things. All right. That's going to do it for this video. Until next time, stay positive, and I will see y'all later for the rest and remaining part of worksheet number 3, which this is by far the hardest part, so I'm sorry in advance. Bye! Well, welcome back to another episode of Math with Son. I realized I made a mistake in the previous video. I'm pretty sure you caught it, but I didn't. I went from number 30, and then I skipped all the way to number 46. So I'm going to finish up that video real quick. I'm going to do a few more of these, and I think that you might just need a little bit more practice with it. We'll go from there. I'm sorry in advance. Here we go. Let's do a few more of these. We've already done some of them. We had, as a review, 3 formulas that we had to use. If they are independent, probability of A and B is equal to probability of A times the probability of B. Probability of A slash B, or given B, is equal to this divided by that, and the B is on the bottom, and then the A here would be on the bottom. So you see a slash over A. This slash, this A right here means that A is on the bottom. Okay? Let me scribble that out. So let's do a few more. All right? These are independent events. So probability of A and B, if we have probability of A and probability of B, you just have to do 7 over 10 times 9 over 20, and that would equal the probability of A and B. Because that's what the formula says. Probability of A times probability of B equals probability of A and B. So we just multiply those two together. No problem. I can multiply things in my calculator. Fractions, forget it. Why would I do fractions outside of my calculator? Times 9 over 20. I got 63 out of 200, and that would be my answer for the probability of A and B. Yippee. Next one, we got probability of A is 3 over 5. Probability of B, we don't know, so we have to multiply by the probability of B. That would equal 39 out of 100 because, again, probability of A times probability of B is equal to probability of A and B. So these two things are multiplied. We have to cancel them out by dividing. So we are going to divide by 3/5. That will cancel. Divide by 3/5. I'm going to rewrite it because I got into the crick in my thing. So we have 39 out of 100. We have to divide by 3/5. Okay, 39 out of 100 divide by 3/5. 39 out of 100 divide by 3 out of 5. See it in my calculator. I hit enter. I get 13 out of 20. So the probability of B is 13 out of 20. There we go. All right, let's move right along. I'm going to jump to a few of the given ones. We've done some of these to death, I think. I'm going to do, well, we'll do one more, and then I'm going to jump to the given ones, okay? These one with these slashes, because we didn't have a lot of those in the previous video. Probability of B, 1 over 4. Probability of B is 1 out of 4. Probability of A and B is 1 out of 8. So we have to do 1/4 times probability of A would equal 1/8. Why? Because probability of A and B multiplied together equals probability of A and B. So these two things are multiplied together, but in order to get rid of the 1/4, we have to divide by 1/4 to cancel it out. So I have to divide by 1/4 on this side. And if I do that, if I do 1/8 divided by 1/4, 1 over 8 divided by 1 over 4, I get 1/2. So the probability of A is 1/2. By the way, little trick, these are always going to be fractions. Every answer has to be a fraction because it's a probability. So it's going to be a fraction. It can't be 1.5. You can't have a probability of 1.5. You can have a probability of 1/2, but not 1.5. So if you get a whole number or a bigger than 1 number, you got it wrong. All right, let's do a few more of these. I haven't done many of these from the previous videos, so let's do a few more. I'm going to probably do, I'll try and stick to the even ones, so that leaves 3 problems for us, okay? So these have a different formula. Here they are right there. I'm going to write the formula for you. This one has probability of A and B. We need to find the probability of A slash B. So we need to use the A slash B formula, which is this one right here. So probability of A slash B, which stands for given B has already occurred, will equal probability of A and B. Probability of A and B is 27 out of 400 over 27 out of 400 over the probability of B, which is 3 out of 10. So we just type in 27 out of 400 over 3 over 10. You can do a double fraction if you wanted to in your calculator. I can do that. I would do 27 over 400 over 3 over 10. Now, if you don't like that, which I honestly don't know if I do, then the other option you can do is fractions just mean divide. So you can do 27 over 400 divided by 3 out of 10, and it would do the exact same thing. 9 out of 40. All right, let's do another one. Said I would do the even ones. I'm going to hold to that. Let's do the even ones. I dropped my formula sheet. I got to pick it up. Got it. Okay, 42. We got 9 out of 10, 20 for the probability of A or B. Uh-oh. Problems. Problems. We have not done an A or B problem. And we are not going to. I am making an executive decision that without, at least without a full-time, like, teacher, we're not going to do anything with an A or B. I promise you. I'm the one making the summatives for right now. I will not be doing that for you guys. And look at that. That was the easiest thing we've ever done. We cancel those out, and we are done for the day. All right. Until next time, stay positive, my friends, and I will see y'all later. Bye.